Today we're going to be talking about colligative properties. So colligative properties are properties of solutions only, okay? And they're properties that are they're properties that are attributed to solutions because they depend on the number of solute and solvent particles, okay, not the identity of the solution. So these properties are always true for every solution because it depends on basically the number of solute particles that are in a particular solution. So they are properties that only apply to concentrations of solutions, okay? Depends on the number, not what it is, okay? So let's go through, there are 4 of them. Okay, the first one is vapor pressure. So what vapor pressure is it's talking about the pressure of the gas. So if you guys look in these 2 containers, right? If you look at the pressure of when the liquid turns into a gas in a closed container. Okay, so this would clearly have a higher vapor pressure than this. All right, this one is your pure substance. You can see there's only blue, and those are going to represent your solvent particles. Okay, and here this is going to be our solution, and we can see we've got a solution of pink particles. Doesn't matter what they are. We can say that they're salt, we can say that they're sugar, we can say that they're another chemical. Those are going to be, the pink particles are going to be your solute. Okay, so this is a solution. All right, so what you can notice just looking at these pictures is that in the solution, we actually have a lower vapor pressure than in the pure substance. Okay, we have less particles that are in that gas form. And if you think about it, the colors are reversed in this section, but these particles right here, the red ones, are trying to get into a vapor, but there are some blue ones that are kind of in the way. Okay, so this pressure getting up into the gas phase is going to be lower in a solution. There's other solute particles in the way. So the vapor pressure of a solution is lower than the vapor pressure of a pure solvent, pure substance. Boiling point elevation. So boiling point is tied directly to vapor pressure. All right? And so if you guys look at the same 2 pictures, okay, we're talking about the basically the change from liquid to gas, okay? And you're going to have to raise this one right here to a much higher temperature in order to get the same number of particles into that gas phase, okay? Because, just like we said, the solute particles get in the way. Okay, so we need to have more motion from these water particles so that they can evaporate into the gas form. Okay, so the way that we're going to do that is we're going to increase the temperature of my liquid so that I can get more gas particles up there. Okay, so you need to increase the temperature in order to have the gas molecules, the liquid molecules, become a gas. So freezing point works the same way. I'm just going to do a quick little example. I'm going to have 12 dots that are going to represent my solvent particles. So I've got 12 waters here. This is going to be my pure substance. And right here I've got my solution. Okay. In my solution, I've got some X's. Okay. The X's represent your solute. Okay. So like salt in water, for example. If I'm looking at this pure substance, these molecules are going to be able to get nice and close together when I lower the temperature. Okay, they're going to get nice and close together, nice and close, okay? However, these ones aren't going to be able to get as close because they have these solute particles in the way. Okay, so it's going to take a much lower temperature to get these 12 particles close enough together to become a solid. So that's the difference with freezing point depression. You need to have a much lower temperature, which is good for us. This is what we use in the roads when it is salty out, okay? Not salty out. We use in the roads for salt when it's snowy out, okay? We can put sand or we can put salt on the roads. And basically the advantage of the salt is that it breaks apart into ions. So instead of just having 1 particle, you're actually going to have 2 particles, okay? So that gives you a little bit more bang for your buck, and so we use those salt particles, all right? All right, so the 4th one is osmotic pressure, and what osmotic pressure is we're talking about osmosis, and basically we're talking about a solvent, which in most cases is water, passing through a semi-permeable membrane from one solution to another. Okay, so from one solution to the other. Okay, so if we talk about semi-permeable membranes, it operates kind of like a soccer net. So if this is my soccer net, all right, and you kick a ball, okay, the soccer ball is not going to go through the net, assuming that there are no holes in the net, okay? So it's not going to go through. But if you take a baseball or a lacrosse ball and you throw it into a soccer net, it's going to go straight through, okay? So it catches the soccer ball because it's a bigger particle, but the tennis ball or the lacrosse ball goes straight through, okay? So it allows some things to pass through, but others not. That's what semi-permeable means, right? So what we're going to talk about is our water particles passing through our membrane, all right? And what's going to happen is we're actually going to have particles going from where there's a low concentration of solute, like that, and this is going to be our high concentrations of solute, okay? So the water is actually going to move from this one to this one, okay? From the low solute concentration to the high solute concentration. This will decrease the molarity of this one, and it will increase the molarity of this one so that the molarities are equal to each other. All right, so let me say that again. If the dots are the solute particles, okay, the water is going to move from here to here so that the water, so side A, the molarity increases when I remove the water. Okay, it's like evaporating off. And here, this concentration is going to get diluted when I add water of side B. Okay, the molarity is going to go down when you dilute this. Okay, so that's what's going to happen in our osmotic pressure situation. So that's the last one that you guys need to know about.